Hello everyone, welcome back to this course on finite element analysis using ANSYS Workbench. In this session, I'll be covering the content in detail that we are going to learn in this entire course. This video is going to be a little bit lengthy, so you have to bear with me because I'm going to capture all the details that will be covered in this course. The main intent of this course is to help the engineers, researchers, scientists, and the educators to deliver value in whatever the work they are doing. Before I jump into the content, I would like to introduce about myself. I'm an industry professional with a 15 years of experience. I worked in multiple domains of engineering in automotive sector, retail sector, home appliances sector, railway sector, medical sector, water filtration sector, and a manufacturing environment for the companies across the world. I also have contributed to revenue growth of the organizations and developed many engineers year on year by sharing the knowledge. Along with that, I trained many researchers, scholars, and students across the globe who are trying to solve their problems and add value to their research work. And in my career experience, I have led many engineering departments and center of excellence for simulation for solving many problems. My entire career was into the engineering problem solving through the simulation based design that makes the product robust and reliable. In this video or in this course, I will be sharing all my experience and knowledge which is helpful for you to solve the problems that you come across during your academics or maybe in your projects in the organization. First, we will be going through the understanding of the workflow. Any of the finite element analysis we take, it is going to be of three stages, that is pre-processing, solution, and the post-processing. By considering the examples, I'm going to discuss of these three stages and make you familiar in problem solving. The next point is the model preparation. In the model preparation, it is very important that any geometry that you come across for solving the problem, it has to go with the conversion of 3D geometry or a model from the finite element model or a mathematical model. How it will be converted from a geometry to mathematical model, how the loads and boundary conditions will be applied, and how the problem will be solved to obtain the solution. In this, we also discuss about the material definitions and the interfaces that the bodies come across, the boundary conditions, loads, and geometry considerations. Then we also discuss about the geometry cleanup. Whenever a geometry comes from the engineering department to the simulation department for conducting the finite element analysis, maybe to understand the pressure or the stresses induced due to pressure or the deflections or the behavior of the model, the geometry will not be regular. It will be having some complexities and intricate profiles that need to be taken care before making the finite element model. And that can be done by simplifying the geometries. We also discuss about how can we remove the non-critical features which does not matter for the strength of the part so that the computation becomes simple. Then we discuss about why exactly meshing is done. If you can look at the model on the right hand side, the geometry has been converted into a small blocks over here. They are called as finite elements. This is no more a geometry now. Geometry was just a surface that was utilized to create this kind of mathematical model. The way we construct our homes with the bricks, likewise, in the finite element analysis, the geometry is replaced with these finite elements and it represents the actual geometry. We discuss about how the calculation happens in the finite element analysis, how the results are extrapolated, and how the accuracy of the simulation will increase with the increase in the mesh size. Then we will discuss about the elements, that is either a 1D element, a 2D element or a 3D element based upon the application, whether the geometry can be simplified to 1D or 2D or whether it has to be considered for 3D itself. In detail discussion about these things will be done when we were discussing about the elements. We talk about their degrees of freedom. We talk about the special type of elements like mass element, spring element, damper element, gap element, which are very critical for building the connections or defining certain objects without directly considering them. We also discuss about what are those different types of elements, what is significance of those elements. And we also discuss on the linearity and non-linearity of the elements, their applications, and what are the shapes of the elements. Like when we look at on the right hand side that the geometry has been converted to a finite element model, and this finite element model is having the elements of certain shape. This one looks like a brick element. We also call that as a hexahedral element. This shape of the element can be either tetrahedron as well, or it can be of a penta element with the 5 sides. With the 3D element, we can have the linear element and the quadratic element, which we can discuss in detail in the sessions. Then we will discuss about the choosing the right element size, because whenever we are conducting the finite element analysis, the one of the question all the finite element analysis engineers will be having is what should be the appropriate element size that has to be selected for solving this problem. That challenge, answer to that particular question will be addressed in this course. Then the element size also depends, or the result of the problem, the accuracy of the result also depends upon the element size. How do we work to attain the correct solution to the given problem by selecting the right element size will be discussed in this course. Then whenever a finite element model is built for any given geometry, the finite element formed should comply to certain quality standards of the finite element analysis. What are those quality aspects? How can we ensure the finite element model built is ready to go for the solution? There are going to be some acceptable limits for the deviations and critical quality checks that need to be done, and we have to identify the distorted elements and improvise on the quality of those elements. We are going to discuss on all those things in this course. Next is the meshing techniques. There are many meshing techniques that we can adopt when solving the problem, because to obtain a brick shaped element always to all the geometries may not be practical. If at all it is practical also, it is going to be time consuming. So a thought has to be given on the time that is available to conduct the simulation and the quality of the element that we are going to obtain, or the results that we obtain out of that particular simulation. So as we can see here that the same object can be meshed with the different element shapes and which still represent the actual model. So which of the mesh that suits good or produces a good results for the analysis, we are going to make a decision. So how that decision will be made will be discussed clearly when we discuss about this meshing technique. Then we move on to the material properties. Material properties are going to be either isotropic, anisotropic, or the orthotropic material properties, wherein we are going to identify the materials and their behavior and the properties of the materials from the ANSYS library. If at all it is required to define a new material, how do we define the material? How do we add a non-linearity to that material will be discussed. Then we talk about the nonlinear material properties. All the objects or all the materials have the nonlinearity, but most of the times the analysis will not be conducted for the materials beyond the yield limit. Always we want our design to be safe. Materials will be analyzed within the safe limit. If it crosses the yield limit, then we are going to strengthen the part or change the material. But if at all we would like to understand the failure of the material and we would like to replicate the actual testing, then we have to consider the non-linearity of the materials. How do we define this non-linearity into the computer, and what are the details that are required, and what properties are critical to define the non-linearity, when the non-linearity of the materials can be utilized, when to use the bilinear material property and a multilinear material property. We are going to talk in detail. Then we understand about the advanced material properties. In the advanced material properties, it is of the material which are having a very different behavior than the elastic materials. For example, hyperelastic material. You might have come across objects like O-rings, which are used in the sealing applications, and for the isolation applications like the gasket used in the refrigerator door frames. So how they are different from the basic material properties, how to compute a material constant from the experimental results, and what are generally challenges that we face in the finite element analysis when we are dealing with such advanced materials, we are going to discuss. The next important aspect is the coordinate system. Coordinate system is a kind, we also call it as a triad, with reference of which we are going to define the loads and boundary conditions for the given problem. So these coordinate system either can be Cartesian or can be of cylindrical. Let's say we wanted to apply the load to a particular body at certain angle, then the coordinate system has to be defined at an angle so that the force is going to reference the coordinate system for application. Then we discuss about the contacts. What are the different contacts? What are the types of the contacts? What are the contact algorithms? How to deal with the contacts, and how to choose the contact and target surfaces will be discussed. So if we look at this particular example, it is having a connection from clamp to shaft and bolt with the clamp, nut with the clamp, and clamp with the shaft as I discussed. So how to define a resistance or a skin between the interfaces so that when the bolt is torqued, the clamp does not interfere with the shaft, but there is going to be a resistance layer with which transfer of forces going to happen between the bodies. Then we'll talk about the load step concepts. So when to use the load steps. If we talk about an example of a 3-point bending, that we have a hollow tubular structure at the center which is supported on 2 supports, and the load is applied from the top. Application of the load and retrieval of the load is a 2-step process. This is called as load stepping. How do we deal with that particular load stepping, and how to make the loading gradual, uniform, and capture the behavior of the tube throughout that bending process will be discussed in detail when we talk about the solution process. We also understand linearity versus the non-linearity response, and what exactly is the difference between material, contact, and the geometric non-linearities by taking simple examples. Then we will discuss about the solution algorithms, like how it is going to be for the transient problems, eigenvalue problems, implicit and explicit problems, why the algorithms, different algorithms are used for the matrix used for the analysis will be discussed. Then we move on to the convergence and controls. Convergence is one of the important aspect in solution of any finite element analysis problem. Most of the people struggle, or some of the people doesn't even know that convergence is one of the key factor when we say that problem is progressing in the right direction. How do we monitor this particular convergence? How do we locate this force convergence? How the force convergence is going to look like with respect to the time increment when the solution is progress? We are going to discuss in detail. Then we talk about the different types of analysis in detail about transient analysis, modal analysis, and the harmonic response of the structure when they are excited or loaded with a certain magnitude of the load. Understand the natural frequency of the structures and their response due to the impact loads. Then we can move on to the post processing. When the results are produced, we have to post process the results by looking at the videos, the behavior of the structure, and extracting the required results, and how actually in the simulation software the results are extracted and extrapolated to the elements. All these things will be discussed in the when we deal with the post processing technique. Then we have to check the behavior of the objects when the analysis is complete. This is going to give us a visuals about the behavior by the animation, and how can this behavior will be scaled for the better visualization purpose. If at all we wanted to monitor the results at key locations, how can we probe those locations, and how to obtain or study the results and the contour continuity we are going to discuss. Sometimes you might have come across that as we go on refining the mesh at certain locations, the stress singularity will be observed and there will be a continuous increase in the stress. How the stress singularity can be reduced, what are the techniques that we can adopt, will be discussed when we are post processing the results and troubleshooting the problem. Then we discuss about how to plot the results like strain, stress, reaction forces, the principal stresses, directional deformations, all those things. What is the technique that we can capture these results will be discussed. Then we discussed about path and result linearization. What exactly is the stress linearization, and why the stress linearization is important? How can we extract the results across along the path of certain locations to understand whether the stress distribution is happening uniformly or not? Then we extract the results to Excel by the computed values that will be exported to a text file. From there we can plot the graphs. In ANSYS also we have the options to plot the graphs. If it is not possible, then we take the data from software to the Excel and study the trend of the graph. Then we go for the evaluation, whether the strength assessment or the strength is of the part is acceptable or not, and we also assess that particular design against the criteria. The considerations for the yielding, buckling and the resonance will be discussed, because by conducting the analysis we are going to get the result or result like deformation, stress and strain. But if they are not complying to the strength of the material, then we have to work on strengthening those parts or changing the materials or with a different design considerations. How do we assess that particular thing? We are going to discuss in the evaluation phase. Then we are going to discuss about the very peculiar analysis, that is fatigue analysis, how to use the stress strain results in the fatigue analysis, Goodman diagrams, and little bit about the fracture mechanics. Whenever a body is subjected to a repetitive loading, then the body is going to experience a bending continuously, which is going to lead to the failure of the part. Then, as a professional or as a researcher, whenever you want to present this study to the bigger forum, what matters is how do you consolidate your study into the report. Report generation is one of a key skill that we have to adapt for presenting whatever the work we have done. How do we consolidate all these results and make a report to convey the meaning out of the simulation we are going to discuss in detail. Report generation and then scope for the improvement are the two important things, because that is going to give an opportunity for the next actions after the simulation. Then we will be discussing about in detail problem solving by taking the examples as I was showing, that either it is a transient analysis or the modal analysis, or be it a contact analysis to understand the non-linearities, be it a geometry non-linearity problem to understand the actual deformation, or be it a bending test to study the behavior of the tube, or be it a simulation to understand the effect of pressure on the tank by extracting the mid surfaces and using the shell elements. How can we simplify the geometries by to a 2D example or a 1D example, or considering like a plane stress and a plane strain examples, and solve them without compromising on the results. So this is insight about the content that we are going to cover in this entire course. You can be in touch with me on 9481635839. This is a India number. You can be in touch with me either in a phone call or a WhatsApp. You can write me an email caewwhelp@gmail.com. You also can visit to my YouTube channel, that is youtube.com channel GRSCADCAE. All these examples or the geometries that we are going to cover, I am going to share it with you based on the request. I am going to meet you in the next session. Till then, take care and bye bye.